All right, let's talk about something you've probably held in your hand 1,000 times, but maybe never really thought about. We're going to peel back the layers on a true marvel of microengineering, the simple pharmaceutical capsule.
Seriously, think about it. You know what it is, you know what it does. But the story of how it's made, what it's made of, that's where things get really fascinating. This isn't just a tiny plasticky container. It's an incredibly sophisticated and precise drug delivery system.
So first things first, you've got two main families of capsules. Over here, you have your hard capsules, which we can call the two-piece. This is the classic design you think of for powdered medicine, right? A longer body and a shorter cap that just clicks right over it. And then you have the soft capsules, or the one-piece. These guys are single, totally sealed units, and they're perfect for holding liquids or pastes. Think of your fish oil or vitamin E supplements.
Okay, so what is this stuff? This shell that has to hold everything together perfectly on the shelf, but then dissolve just as perfectly inside our bodies. Well, let's get into the secret ingredient that makes the whole thing work. The hero of our story is gelatin. Yeah, that gelatin. And its magic really comes from its origin story. It's a protein that comes from collagen. When it gets processed, it creates this just amazing material that can form a super strong yet flexible film. And that is exactly what you need to create a shell that's both stable and digestible.
Which, of course, leads to the next question. If gelatin is made from collagen, where do we get the collagen? The answer might surprise you a little bit.
That's right. For industrial-scale production, gelatin is made from the byproducts of the meat and leather industries. It's actually a pretty long process, can take weeks of treatment and boiling. But at the end of it all, that collagen is extracted and turned into the pure, tasteless, and odorless gelatin we use in medicine.
So why stick with gelatin? I mean, why is it the gold standard? Well, because its properties are pretty much perfect for this job. For starters, it's non-toxic. We use it in food all the time. It dissolves super reliably at body temperature, right around 37 degrees Celsius, and it forms this incredibly strong, uniform film. Manufacturers have even gotten so precise that they blend gelatin from different sources, like bone and pork skin, to fine-tune the final capsule for the absolute perfect mix of toughness and clarity.
So now we know what they're made of, but how do you actually make one? Well, those two types of capsules we just talked about are created through two totally different and frankly equally brilliant manufacturing processes.
Making a hard capsule is kind of like making thousands and thousands of tiny little candles all at once. You have these rows of stainless steel pins that get dipped into a big vat of warm gelatin. Then they're spun around to make sure the coating is perfectly even, and they travel through these long, drying kilns. Once they're dry, the two halves, the cap and the body, are gently stripped off the pins, trimmed to an exact length, and then joined together, all ready to be filled.
Soft gels, though, are a whole different ballgame. The engineering here is just so clever. The best way to picture it is to think of a ravioli maker. You've got two continuous ribbons of warm, pliable gelatin rolling between these rotating dies. Right at the exact moment the two halves of the mold meet, a super precise dose of liquid is injected inside, and the heat and pressure from the dies seal and cut the capsule, all in one beautiful fluid motion.
Of course, the shell is only half the story, right? The real point of a capsule is what it delivers, and their versatility in what they can hold is just as impressive as how they're built.
I mean, this is why capsules are one of the most versatile options out there. They can handle almost anything you can throw at them or, put in them. Dry powders are the most common, sure, but they can also be filled with granules, little pellets, thick pastes, suspensions, even a huge variety of oils. Basically, as long as the liquid inside isn't going to dissolve the gelatin shell, it's fair game.
And to make sure all that versatility translates into accurate doses, capsules come in a whole range of standardized sizes. They go from this big 00 size that can hold over 600 milligrams of stuff, all the way down to a tiny little size 5 that holds just 90 milligrams. This gives drug makers incredible flexibility to get the dosage just right.
And the scale that these things are produced at is just mind-boggling. Get this. A single modern sorting machine can process 150,000 filled capsules every single hour. In that time, it cleans off any loose powder and automatically kicks out any imperfect capsules. It's all about making sure every single one is perfect.
But hold on, before any of those hundreds of thousands of capsules reach you, they have to pass a whole battery of tests. This part is all about quality, safety, and looking ahead to what's next for this amazing little piece of tech.
Yeah, every single batch goes through some seriously strict quality control. They do a disintegration test to make sure the capsule dissolves exactly when it's supposed to in body temperature fluid.
They do a weight variation test to check that every capsule has the exact same amount of medicine inside, and a content uniformity test makes sure the active ingredient is consistent from one capsule to the next.
So after all that brilliant engineering, what's the one thing that can bring it all crashing down? It's humidity. You see, the gelatin shell needs to keep a very specific moisture content, right around 13 to 16%. That bit of water keeps it flexible. If it gets too dry, it turns brittle and can crack. But if it gets too humid, it gets all soft and sticky. So yeah, proper storage is absolutely critical.
And you know what? The capsule is still evolving. While gelatin is still the king, there are modern alternatives popping up. The most successful one is HPMC. It's a plant-derived material. This is great because it offers a vegetarian and vegan-friendly option. And because it has different chemical properties, it can dissolve differently, which opens up a ton of new possibilities for drug delivery.
So from what looks like a simple shell to what's actually a high-tech delivery vehicle, the capsule really is a masterpiece. And it kind of leaves us with one final thought, right? As medicine gets more and more advanced, we're talking targeted therapies, complex biologics. What incredible new payloads will the capsule of the future be designed to carry? The journey for this little object is definitely far from over.